Now let's get right into multiprocessing. So yeah, we don't need any of this now. Just remove or comment this out. Okay, so let's get started. So we mainly have two different ways, just like we saw threads. We have a manual way, and we can actually do in a newer way or a better way using the concurrent.futures module. But first, let's take a look at the manual way using the multiprocessing module. So I'll just simply say import multiprocessing as, let's give it a short name. I'll say MP for here, and we are going to import the time module just to calculate the time that it actually takes. We can also import the math module because we are actually going to do some calculations here to actually see the time difference between the time difference that we actually take while using multiprocessing and while not using multiprocessing. So let's write a program to actually do a simple calculation, and let's see the time difference they are actually going to take. So I'm actually declaring three lists here called result A, and we'll set it to an empty list. We'll actually add values later. We'll say result B, and we'll also set it to an empty list. We'll do a result C similarly. So we are having three results here. Now we actually have to declare three functions. So I'll explain to you all this stuff after we complete this. Now let's just keep on going. So I'll define a function called make calculation, one, and we'll take a parameter called numbers, and we'll just loop over those numbers because we are actually going to take a list of numbers. So we'll say for number in numbers, and then we'll just add these numbers. We'll just say result A dot append. We'll not simply just append those numbers, we'll do some basic calculations and we'll just add those result to this number, so to that list actually. So if I just say math dot square root, so we are actually going to calculate the square root of the cube of those numbers. Seems pretty complicated, but it's pretty simple actually. So what we are basically doing is, here we are actually calculating the cube of the number first, and then we are actually squaring it, and we are actually appending it to the list for each numbers in a list of number, or for each number in a list of numbers. So we are actually going to make three similar functions so that we can actually run concurrently and check for the results. So we actually have to say we actually have to change this to 2. Everything else is the same. We have to change this to B, and finally another function, and finally we'll change this to 3, and we'll just change this to C, and that's it with our functions. We'll actually make some small modifications here. So instead of cubes, we can actually do a 4 here and 5. We're just making it to work slow. We are actually trying to slow it down with some calculations, with some numbers. So now we are actually going to use the main function. We are not using multiprocessing right now, and this is not necessary, but we are still using it. This can be used with normal programs as well. So we'll say if name is equal to main, we'll say num list. We are actually passing those numbers here. So I'll say list of range of numbers. So I'll actually do a lot of numbers. Okay, so you can reduce a 0 here. Another 0. This should be fine. Now Now we actually are going to calculate the start time and the end time. So we'll do that with the time module. We'll say time dot time, that will actually calculate the current time, and then we'll execute those functions. So we'll say make calculation 1, and we'll pass in the num list as the argument. We'll do the same with the other two functions. And we'll do the final one, 3 num list. Yep, that's it. Now let's actually calculate the end time, and we'll actually have to calculate the difference between the start time and end time to actually uh, calculate the time the program actually took. So yeah, now I think we are pretty much done. Let's just print out the difference between the start time and the end time. Yeah, that's it. Okay, end minus start actually. Yeah, that's it. We are looking good. Let's just run this program. I'll just say run mult. Let's just wait for this program to get completed. This is actually going to take a little bit of time, and it can actually depend on your computer processor speed. I have an i7, so mine is actually pretty good. So yeah, this thing got completed in 11 seconds. Yours may take longer or shorter depending on your processor or your general system power or general computational power. So it actually took 11 seconds here to actually calculate 10, to actually do this calculation. So now let's actually use processing or multi-processing, and let's see how much speed up we can actually get. Okay, we have actually imported multi-processing. We now need to just use it. So I'll just come here. We can actually do both of them, and we'll just see the speed difference. So I'll say P1 is equal to MP dot processes, and we have to, this is actually similar to the threading module. We have to specify the target function, and target is actually make calculation 1 without executing it, and we have to pass the arguments as args, and we'll say num list. Okay, we have to actually pass in a tuple here. This is not, so we have to actually pass in a tuple here. So we'll say num list, and we have to actually specify a comma after that, because we actually have learned before. So if we need to specify a single item inside a tuple, we have to actually use a comma after that. This is a valid tuple. Now we need to just copy this now, and we can create two more processes. So we'll rename them. We'll say P2 and P3, and we'll just have to rename the functions as well. I'll say 2 without executing it, and 3 similarly. Yeah, now it's actually done. Okay, now we are actually again going to calculate the start time and end time for this one. So we actually did it while actually executing it normally, but now we actually have to execute this in processes, I mean as multi-processes. Now let's calculate the end time is equal to time dot time. Now inside this we have to actually start our processes. We actually did similarly with threads, so we'll have to say p1 dot start, p2 dot start, and p3 dot start. So we'll just say p2 dot start and p3 dot start. So now we are actually good to go. We are actually doing some calculation, and then we are actually calculating it using multi-processing, and then we are actually doing it normally, and we are actually printing out the time. Okay, we haven't printed out the time, I think. So I'll say print inside an f string. We'll say multi-processing, just so that we can actually identify which one was which. So we'll say end time minus start time. So yeah, that's it. Now I think we are good to go. Let's just execute this. let's say, let's just see how much time it actually took. Okay, so it actually completed in 1 second. You kidding me? It actually did all this calculation in just 1 second, and the other one actually took 11 seconds to complete. We can actually get more speed ups by just increasing this number a little bit. So instead of 1 million, I'm actually choosing 5 million here. So let's just rerun the program. Let's see what speed up we can actually get. I have run the program. Okay, my CPU fans are actually spinning really fast, so I'm getting a 9 second here using multiprocessing. Now with normal method, let's see how much it is gonna take. Okay, it's actually taking too long. It should take maybe 15 to 20 seconds. I'm not sure. Okay, so we are actually done. So after struggling for 110 seconds, my PC actually managed to do this. But with multiprocessing, we were just able to split the task into different processes, and we just completed in just less than 1/10 of the time. Here we just did it in less than 10 seconds. Here it actually took 110 seconds, and my PC actually froze for a few seconds. And uh, so now we actually know why it is actually better to use multiprocessing than normally doing such heavy tasks. So this was actually the manual method. We can also use the concurrent.futures method to actually do this thing.